Alright, so let's take a look at today's lesson. So we are looking at analyzing data day 2. Let's kind of review what we've done so far with statistics. We talked about on the first day different ways to organize the data. Right, we looked at line plots and histograms, just different kinds of things. Stem and leaf. Yesterday we focused on standard deviation and variance and measures of central tendency. Basically we're looking at comparing numbers to the mean. That's what we looked at yesterday. The standard deviation is how far from the mean are the numbers. So we're focusing on the mean yesterday. Today we're going to do a different, so yesterday with the standard deviation was a measure of dispersion, right? How far is the data dispersed? This is also a measure of dispersion, quartiles, but instead of comparing to the mean like we did yesterday, quartiles are all about the median, comparing to the median. So that's really the difference between these two measures of dispersion, is one measures from the mean and the other one measures from the median. So let's look at quartiles. How does it work? So when I think lower quartile, really, with English, I'm thinking like a whole section of data. That's not really what it's talking about. It's going to be one number. The lower quartile is one number, and the upper quartile is one number, not a whole section of numbers, not like a fourth of the numbers. So if we look at this little diagram right here, it kind of helps us. The middle number, which we know as the median is Q2. Those are the same thing. Q2 and the median are identical. So the second quartile is the median. Then we look at what they call the lower half of the numbers and the upper half of the numbers, which makes sense. We've already cut it in the middle by the median, right? And then so we have halved the data. So now we have the lower half and the upper half. Well, the median of the lower half is Q1. Again, notice it's a median. We're dealing with just medians, middle numbers. The median of the upper quartile is Q3. And that's how you find Q1, 2, and 3, is basically just dividing the numbers in half, in the middle, and then the lower half in half and the upper half in half. That's all it is. It's just the medians. So we also have something called interquartile range. So hopefully we understand what quartiles are, right? We know Q1, Q2, Q3, they're just medians of their portions of the data that they're measuring. Interquartile range is the difference between the upper and lower quartile. So basically it's Q3 minus Q1. It's just a formula. Interquartile range is Q3 minus Q1. We subtract those quartiles and we get our interquartile range. They also have a special diagram, if you will, on how to display this data. The quartiles, and it's called a Box and Whiskers Plot. That's this right here. This is our Box and Whiskers Plot. So really there are just 5 numbers on here, and if you hear 5 number description, they're talking about these 5 numbers, the 5 numbers. So we have the minimum number, the very smallest number of our data, and we have the maximum number, the very largest number in our data. Those are the ends of the what they call whiskers. Those are the ends. In the middle is a box that kind of highlights our quartiles. So our lower quartile would be the beginning of the box, and our upper quartile would be the end of the box. Our median would be, just shown in the box in there where it belongs. Now this looks perfectly symmetrical, this Box and Whiskers Plot. This is actually quite unusual that it be perfectly symmetrical. And really just by chance the example I gave you is kind of symmetrical. But I want you to understand that that's not normal. It's not necessarily normal that it's symmetrical. Sometimes this box could be moved far to the right or far to the left. It just depends on the numbers, right? And we're just talking medians. What if we had like 51s and then, some other numbers? About 10 other numbers. Well, we're going to have a really skewed, it's not going to be in the middle like this, is it? The box isn't going to be in the middle. So just be aware that that's just, this is by convenience. It's not normally symmetrical. And I really like symmetry, so it's a little bit troubling that it's not normally symmetrical, but it is not normally symmetrical. Okay? So that's all the stuff that we're going to deal with on quartiles. Any questions on that concept? All right, the second concept that we're looking at today, we're going to really go a little bit deeper into standard deviation, what we were looking at yesterday, and talk about the normal distribution or the bell curve, the bell-shaped curve. That's a really big topic in statistics, is normal distribution. And in the word problem that you'll be looking at, if you see the word normal distribution, they're talking about this. It's like a keyword. That word means something. That's why I like that example I had on yesterday's daily work. It said normal distribution. I was like, oh, we haven't got to that yet. So that's why we didn't do it. Well, we could do it after today. So let's kind of look at what does that mean, a normal distribution. And actually, there are some professors in college that grade on a bell curve, on a normal distribution. So, yeah, it just kind of, they just force the grades to be a particular way, like this. So let's look at it. So what does it mean? It means, so here's this Greek letter mu. This is also a letter that they use to show mean. That's a mean. You know, X with a line over it, they also use to say mean. It really just another, who knows why they have multiple ways to talk about mean. Maybe they just really like it. I don't know. So this is the mean. What this is telling us, this is one standard deviation, and this is a sigma. You can't kind of read it, but there's a little tail on there. So the mean minus sigma, so this is saying we are one standard deviation from the mean on either side. When we are one standard deviation from the mean on either side, that accounts for 68% of the data. 68% of the data is one, like say we are, taking information from a population of people, and we say that this information has a normal distribution. Then we could say that 68% of the people that we did this study on were blank, whatever the study is. So this is how we could use this information. If we go 2 standard deviations from the mean, so that would be here and here, 95% of the data, or people surveyed, however, 95% of people would be within 2 standard deviations of the mean. Then we get farther out to 3 standard deviations. 3 standard deviations of the mean would account for 99.7%. I mean, we're talking the vast majority would be within 3 standard deviations of the mean. And then we would have those outliers, which would be even smaller, like, so 0.3% would be, so 0.15% on either side would be outside of 3 standard deviations of the mean. So we're going to use this concept when we work word problems that talk about normal distribution. Okay, questions so far? All right, let's go to the examples. So the first example says to find the lower and upper quartiles and interquartile range for the following data set. Complete a box and whiskers plot for the data. So the first thing that we would have to do is put the numbers in order, right? Because this is all about medians, not about mean. So we need to put the numbers in order. I have already done that, so I'll just write those down for us. So we have 3, then 15, then 23, and 23, then 27, then 39, then 43, 47, 55, 74, 81, and 86. Okay, so now we have them in numerical order. So what we're going to do is we're going to go through and we're going to find the median of the entire set of data. The median happens to fall right here. That's the median. And we know from years of, working with medians, we know what to do when it's like that, split like that. We would average those two numbers. So we would add 39 and 43 and divide by 2, and we would get 41, and that is Q2. Our median is Q2, the second quartile. So now let's go to the lower half of the data, and let's find the median of the lower half. So here's the lower half, and our median happens to be here, which, 23 plus 23 divided by 2 is still just 23. So 23 is Q1. That's our first quartile, is 23. So now let's go to the upper half of the data, which happens to be right here. And it's a little bit different. We would add 55 plus 74 and then divide that by 2, right? Well, that's what we do when we have a situation like that. And we're going to get 64.5. 64.5 is Q3. So these are our quartiles. So that's the answer to the first question. These are all the quartiles. Okay, we okay with that? Then the next thing they're asking for is interquartile range. The interquartile range is simply Q3 minus Q1. It's just a formula. We just subtract the upper and lower quartile. And so our interquartile range is going to be 64.5 minus 23. That's just Q3 minus Q1. And that gives us 41.5. So that is our interquartile range, is 41.5. Okay. Now we're going to complete a box and whiskers plot. So we're gonna display this data. That's probably the best way to display the data is on a plot like this. So we draw, a line. And then at the end of this, would be my very smallest number, which is a 3. And this end would be my very largest number, which is an 86. Okay. Now the box that we're going to draw is the endpoints are Q1 and Q3. And what we want to do is it doesn't have to be perfect. We're doing it by hand, but we want it to be fairly representative of, reality, right? We don't want to just come over here and draw this little tiny box right here and just put the numbers on it. That really wouldn't make any sense, right? So this actually happens to be kind of symmetrical. I know I like symmetry. I really didn't choose this one on purpose, although it'd be kind of fun. 41 is Q2, and it really is kind of in the middle between 3 and 86, right? Kind of in the middle. 41, I mean, not exactly, but kind of. So we want to kind of go to the middle. And I'm not going to label that yet because my box sometimes is crazy. So I'm going to draw the box first before I put the labels on my numbers right here on the points. Then Q1 is 23, which kind of is in the middle between 3 and 41. I mean, kind of, right? So it'll be kind of in the middle. And then Q3 is 64.5, which is, kind of in the middle between 41 and 86. This just works out symmetrically. It doesn't always. And so now that I have these 3 numbers, I'm going to draw my rectangle. So we're creating our box. And now I'm going to put my numbers on here. So this was 23, and that was 41, and this was 64.5. So if we're given a box and whiskers plot, they're not going to tell us, they're just going to give us a picture like that. We have to know what the meaning is. So what kind of questions could we answer with a box and whiskers plot? Really just stuff about the median, right? And we could talk about interquartile range or max and min numbers, but that's kind of about it. We wouldn't be able to figure out what our mean was from that. The average, we wouldn't be able to figure that out, but we would be able to answer those other types of questions. Okay, are we all right on that? Okay, so I'm going to actually draw the bell curve so we can answer number 2. I'm going to need to erase. Does anyone still need that? Okay. So I'm going to draw the bell curve, and we're going to talk about it some more. And I encourage you to draw it as well, because you're going to be using the numbers off of here. I'm not going to be giving you these numbers on a quiz or test. You would have to know, and you would have to know how to create this. So I encourage you to draw it with me. So we have a bell curve. And right in the very middle, that's our mean, and I'm going to use X with a bar on top. For a normal distribution or the bell curve, the mean is exactly in the middle. Then we're going to go out on either side. So out one portion, this would be the mean minus 1 standard deviation. And this would be the mean plus 1 standard deviation. That's what that first part out would be. Then keep going out. This would be the mean minus 2 standard deviations, and this would be the mean plus 2 standard deviations. And the last one that we're going to look at is 3, so this would be the mean minus 3 standard deviations, and this would be the mean plus 3 standard deviations. Now let's think about the percentages that we saw on that other page. We were told that the middle, like 1 standard deviation away from the mean on either side, that constitutes 68% of people. Right? So what I can say is that this little section is 34% of people, or whatever we're working with. And I'm actually just going to work on the left side because this is from the left side, but you know it's symmetrical. So if that's 34%, this is 34%. Okay? So now let's look at the other number. Now these, you'll have to create this, right? You're going to have to know these numbers. So 2 standard deviations from the mean was 95%, right? 95%. And so I've used up 68%. How am I going to get this bar right here? I'm going to take 95 minus 68 and then divide that by 2, right? That remainder by 2. And that's what I did to get this number. So it will be 13.5% exist in this space, 13.5%. Now 3 standard deviations from the mean, that was 99.7%, right? So we would take the difference between 99.7 and 95, get that number and divide that by 2. Right, and that would give us, right here, it would give us 2.35%. And that's not all, right? We have some outliers. We have some things that would be farther out than 3 standard deviations. So let's figure out what that would be. So 3 standard deviations was 99.7. If we did 100 minus 99.7, we would get that left over, right? 0.3, divide that by 2. So right out here on the little end, the little tail right here is 0.15%. Now these numbers are going to be important to us in answering questions that deal with the word normal distribution. That's what they're wanting us to do, is to make judgments based on the actual distribution. Okay, so let's look at number 2. Find the probability for a randomly selected x value from a normal distribution that, and let's kind of pull this apart. What does this mean? So this is what we're looking for, x. X is between the mean and the mean minus 2 standard deviations. That's what x is. So what we're looking at is this space right here and this space right here. That's what we're looking at, right? That's the space between the mean right here, and 2 standard deviations, which is right here. So that's what we're looking for. Okay. All right, so what would that be? So let's talk about probability. We actually are going to do some lessons in probability next week. Probability, the numbers for probability are between 0 and 1. 0 is there's absolutely no chance. It is impossible for the event to happen. 1 means that it is going to happen. That, I mean, it will happen. There is no chance that it will not happen. And then, of course, we have every number in between. So when we're dealing with probabilities, we're dealing with decimals. So instead of looking at this as a percent, I'm going to turn it into a decimal just because it's talking about probability. So I'm going to do 0.34 plus 0.135. That's going to give me what they're asking for, which is 0.475, 0.475. That is the probability that if we randomly selected an x, it would appear in these 2 sections. Are we okay with that? Okay. Now let's look at another application using the normal distribution. Number 3. So number 3 says the blood cholesterol readings for a group of women are normally distributed. Okay, there we go. That's our key word. That tells us we're using the normal distribution of the bell curve. With a mean of 172 milligrams per deciliter. Since I have that graph drawn over there, I'm just going to go put these numbers on the graph. what was 172 is our mean, and it says our standard deviation is 14. So 172 minus 14 is 158, and 172 plus 14 is 186. This is just going to help me because I know they're going to ask me questions that has to do with standard deviations. So there we go. So there's that. So let's keep reading. It says, about what percent of the women have readings between 158 and 186 milligrams per deciliter? Okay, so we have this over here. We can see that. It's going to be this section in here, right? One standard deviation from the mean, which we know is 68%. Now, as we're getting later in the year, I'm going to start transitioning to, we're going to write things like we're going to in calculus. Okay, so we're not going to just write 68% and move on, because that's not what we would get credit for in calculus. So we're going to say what it is. So 68%, and normally it's just fine to read back what they said. 68% of women have readings between 158 and 186 milligrams per deciliter. That's how we write our answers. Okay? For those of us that like to conserve energy, it's just going to take you about 5 seconds longer. It'll be okay. We're just going to write that out. 68% of women have readings between 158 and 186 milligrams per deciliter. All right, so let's look at the next one. Readings less than 158 milligrams per deciliter are considered desirable. About what percent of the readings are desirable? Well, that's just this part over here, right? Lower than 158 would be way out here. And they ask for percent. I mean, it's asking for percent. So I'm going to do my calculations with percent. So we would have 13.5% plus, then we would have 2.35% plus, and then we would have 0.15%. So we add all that together, and we would say about 16% of women have readings less than 158 milligrams per deciliter. Oops. Or you, instead of saying specific, you could say about 16% of women have readings that are desirable. Well, that's not very much, is it? 16% have good readings for cholesterol. Okay. How are we with this lesson? Is this okay?